Welcome to Tech presented by Kaizen, where we will explore common cleaning questions and answers. This session has been pre-recorded and will include additional FAQs related to this specific topic at the end of the presentation. We hope it is 15 minutes well spent. Let's get started. I would like to introduce Kaizen's own Luis Fernando Gascon.
Thanks very much for that lovely introduction, William. Good day, everyone. Today, we will be starting with the last process control optimization series, reviewing all the factors that affect our process in a semi-manual control process. In previous tech-to-tech sessions, we've reviewed the basic process dynamics ongoing inside an inline cleaning application where due to different factors like the exhaust system of the equipment and the inherent drag out, the process suffer losses of both solvent and water at different rates. Although these might seem like small volume losses when added up through all the operating hours, it will definitely alter our concentration percentage in the tank, generating variations that need to be monitored and controlled. We will be focusing on how to control your clean application using a semi-manual process. For this purpose, we will require an automated dosing system like this one, which we are going to call a controller. This controller will help us dispense water and chemical into our cleaning equipment when the washing tank demands for it. Uh, we call this a makeup or top up. Uh, this compensates for the losses mentioned before, allowing us to reduce the variations of the proportion of water and chemical inside the washing tank. It is a very easy and straightforward principle. Chemical and water are lost along the process. So chemical and water needs to be added back into the system to keep the equilibrium. The controller is a water-driven pump that uses the Venturi principle to drive a chemical piston pump that is integrated in the system, harvesting the pressure of the wash tank makeup water line to inject chemistry into the wash tank of your equipment. In other words, every time your equipment demands to refill the levels in the wash tank and it opens the water inlet, both water and chemical at a fixed proportion will begin to flow and refill the levels in your equipment. The controller could be directly mounted and installed over the inline washer, connecting it to the DI water facilities and to the wash tank inlet of your equipment. Or it could also be mounted in our specially designed stand, which allows the unit to be placed just above the chemical drum directly. In either case, the unit will require to be connected to the chemistry drum through a hose from where the unit will be pulling the chemical into the system. The controller uh, contains an adjustment dial that restricts the movement of the piston that is injecting the chemical. This dial allows us to set the desired percentage of chemistry to be injected into our process to refill the loss in levels in our wash tank. This adjustment needs to be fine-tuned to adequately maintain the concentration between your recommended process range. There are different models of the controllers that could be used depending on the concentration ranges in which your process operates. You would have to choose the right one that meets your needs. But of course, you can always count with the technical support from your Kaizen representative to make the right choice. In this case, it is a model 6470. Um, the specs indicate that, sorry, the specs indicate that it can dose in a range between 2.4 to 25% approximately. The dial has a scale that goes from 0 to 10, where 0 means 0% movement of the piston and 10 means 100% of movement of the piston. It is important to notice that this scale does not directly relate to the concentration percentage of the mixture it will be supplying into the process. The reality is that depending on the properties of the chemical you are using, especially its density, uh, the liquid will flow faster or slower through the system. Uh, so your Kaizen representative will support you in setting up the scale to the appropriate number, ensuring the right quantity of chemical is flowing into the system. Let's give a practical example. Let's assume that you are using our newest product generation, an Aqueous cleaning agent, and that the recommended concentration operational range is 15% plus minus 2. Your Kaizen representative would share with you a controller reference table like this one, which will show you the controller dial revolutions required to set up your specific concentration requirements. Before we were showing a controller, which model was 6470. So we will be working with only the red line of the graph, which is set up for that specific model. For a 15% concentration, it says it requires 19 dial revolutions. This would be the setup you will use when you require the controller to make a complete fill up of the washing tank. But once the wash tank is filled, uh, the washing equipment starts normal operation. The setup of the controller needs to be readjusted. When we are starting a process for the first time with a controller, we usually recommend to adjust it at half the recommended concentration for the normal operation of the process. Being that said, we would look to have the controller to be set up at 7.5 percent concentration, which translates into 6.5 dial revolutions. Why is this? You may ask. Well, the reason behind this is that the chemical and water in your specific cleaning process will be consumed at different rates, depending on your equipment design and configuration, the geometry of the parts you're cleaning, temperatures used, and recovering systems that you may have installed. Uh, the sum of all these factors will result in a variation of the consumption of water and chemical. You would usually expect to lose more water than chemical, but even if you have a continuous supply of both, like with the controller, it will always be adding a fixed amount. All the factors we just mentioned will contribute for a concentration to start moving slowly. Since the concentration percentage would still have a variation using the controller, either up or down, you will still require to monitor the concentration percentage of your process in a regular basis by using any of the recommended methods described in previous tech-to-tech sessions. To measure the concentration, then analyze the data readings to find deviations and trends, and readjust the controller setup accordingly. This is a never ending loop that repeats along the time in order to keep your process under control. We recommend that you keep a daily record of how their concentration measurement is behaving. This will help you identify trends like increasing or decreasing of the concentration along the days. Depending on the trends you observe, you will have to adjust the dial of the controller accordingly. You would have to measure the concentration, analyze, then react. And these data logs will be important for you to take the right decision on time and avoid the process falling out of range. An important note is that the tank will always be full. So if the concentration is high, the tank will have to be drained and the controller will have to be bypassed or set to zero dials to allow only water to flow into the tank and dilute the solution. Then reconfigure the controller to the original set point. If their reading is low, chemistry will need to be added manually to increase the concentration accordingly. We analyzed the data from a customer who was using a controller and a manual concentration readings like what I just described. After running it through Minitab SPC, it showed a CPK of 0.37 and a PPK of 0.21. which confirms that the efficiency of this semi-manual process depends entirely on the operator of the process and the continuous monitoring. Semi-manual I would like to compare a semi-manual control versus a manual control. Semi-manual offers different advantages when compared to a 100% manual process. It is a very small investment of money for the controller, which does not require much maintenance, and it is very easy to operate. It allows you to limit the contact of your employees with the chemical handling and harsh process conditions like temperature, pressures, odors, or splashes of the chemical while filling and measuring the process. It still requires the involvement of a person assigned to monitor the process and make corrections when required, but it is in a less scale, which limits the chemical waste caused by human error factor as well. And lastly, this type of process offers more stable and reliable cleaning results than a manual process. For the end, we have prepared these three questions that we get asked often in regards to semi-manual process. The first one, why does the controller need to be adjusted to a lower concentration than the recommended for the process once the cleaning process is operating normally? This is something that people tend to don't understand at the beginning. So, like I was mentioning before, depending on the different factors involved in your specific cleaning process, chemical and water will be consumed at different rates. For starters, water has a boiling point of 100 degrees Celsius. We might not heat the solution that high. Usually it is set up to 60 degrees Celsius, but it is enough to increase the evaporation rate of the water present in the solution. And we lose more of the water from the process through that mean. The chemical has a much higher boiling point, so less components of the chemical are being lost. Usually, we lose more chemical through drag out than we do through evaporation or the exhaust. Therefore, a long time, we would have to replace more quantity of water than chemical. This is why we initially set the controller to have the desired concentration that we want to keep in the process. Once it is fine-tuned to your specific process factors, that set point might be higher or lower than the reference that we just gave, but it is a good baseline to start. Now, the second question is, what cost reductions would I expect from a semi-manual process implementation, right? This is an interesting question compared to a 100% manual application. You could expect to see reduction of hidden expenses. For example, use of extra chemical in your process due to chemical mishandling by the operator. The fact that your process will be kept more stable under the recommended operational concentration range will impact your cleaning quality, reducing defects or failures of your devices or unwanted rework of your products. And you will reduce the contact that the employee will have with the chemical directly, which will impact in your safety risk crimes of your insurances. The third question and last one, can we get training and support on how to set up these type of control processes? This is something that we as a company offer by the simple fact of you being our customer. We make sure to support you through the install and configuration of the equipment required, as well as train you and your operators and your engineering teams on how to fully control and optimize your process. If making you successful is our priority. So with this, the session will be finished. I pass it back to you, William. Thank you very much for your time.
Thanks, Luis. Thank you all for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in this session, please contact your local Kaizen regional manager or send an email to tech@kaizen.com, and we will have someone follow up with you as soon as possible. Do you want to have exclusive access to future content sent directly to your inbox, or do you know someone who would benefit from these sessions? If the answer is yes, just go to tech2tech by Kaizen.com, fill out the subscription form. If you like this video, be sure to follow us on our social media platforms for more expert cleaning content.